Well, howdy, and welcome to Mr. C.
And Mr. Zwick.
Presentation on equivalent fractions. Yes, folks, you have to know your factors and you have to know your multiples. If you don't, stop this video right now, go back and master those concepts. If you don't know what a factor is and you don't know what a multiple is, this is going to be way over your head. You may be able to get it, but it's going to be much more difficult than if you were to master those concepts first, okay? So let's start out by talking about why this even matters. First reason, you have to know how to find equivalent fractions in order to add and subtract them many, many times. Okay, so make sure that you learn this concept so we can start adding and subtracting fractions. And secondly, it's going to help you to think about fractions, right? If you look at 1630 seconds and go, oh my gosh, that fraction is so hard to even understand, you're wrong. Okay, if you know what equivalent fractions are, you know that that's a half. Right? That's like saying you have a half of something, which is really easy to think about. So knowing about equivalent fractions makes that easy. Wouldn't you say, Mr. Zwick?
Oh, of course. And also, a very important thing is in the art of cooking. If you're cooking something, you need to know how many tablespoons go into something. Maybe you need a half of a teaspoon of salt to add to your food.
Right, and like if you know that like, a third of a tablespoon equals a teaspoon, right? You know equivalent fractions and things like that. It's going to help you out while you're cooking. Very well said, Mr. Zwick. Okay, so let's move right along. We're going to take a look at some of these fractions. And I love looking at pizza. I think pizza is the easiest. It's so delicious, right? It's easy to cut up into equal pieces. Every time you get a pizza, usually it's cut into equal fractions, okay? So let's just take a look. Let's start out by taking a look at some of these fractions. I'm going to cut this pizza into thirds. Oh, I screwed it up.
Let's make that a little bigger.
Hold on. Give me one more try. I'm not used to writing from this angle. It's weird having somebody next to me, a co-pilot. There we go, close enough, okay? This is cut into thirds, all right? And I'm going to shade in 2 of these thirds, okay? Imagine you got to eat 2/3 of a pizza. You would be gorging yourself, okay? That is a lot of pizza, okay? That's pretty easy to see, right? Okay, well, we're going to take a look at another fraction. We're going to look at 6/9 of a pizza. And in order to create this fraction, I'm going to do something very similar, right? I'm going to cut into thirds.
Okay, so 1/3 plus another third.
And then I'm going to cut each one of these thirds into thirds, and you're going to watch how it becomes. Oh my God, this is the sloppiest. If you got a pizza and it was cut like this, you would be so ticked.
I don't want that small piece. I'll tell you that right now.
That's right, you don't.
But
okay.
Make sure though that you're looking at what 1/3 plus 1/9 plus 2 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9, right?
Right, we got 6/9 here, so we're going to shade it in, okay? So obviously everyone's going to fight for that piece, right? You're going to eat that piece first. Let's imagine they're all the same size. 2/9, 3/9, 4/9, 5/9, 6/9.
So you just added fractions right there in your head.
Sure.
Added them all together.
Sure. Okay, so we got 6/9. Okay, let's take a look at one more. This one you're going to kill me on, okay? I'm going to be the worst pizza cutter in the world. 12/18. Okay, let's cut this up into 18 pieces. Oh my gosh, how am I even going to do this?
So this, to me, right now, what I'm thinking is you're cutting all equal slices so that everybody that gets to eat a slice gets the same amount, right?
Absolutely.
Okay. Because when I look at it, I see a bigger number and I think, ooh, I want to have that pizza. However,
the bigger one. But let's
might not be.
pretend that they're all the same size.
Yeah.
Okay, we are pretending like all these pieces are the exact same size. Is there 18 there? Did I screw this up? I don't think I did. I think there's 18. Okay, look at that. Oh my God, if my pizza came cut up in 18 pieces, I would be ticked. But now we're going to have 12 of these. 1, 2, 3, 4, 5, 6, 7 18ths, 8 18ths, 9 18ths, 10, 11, 12 18ths, okay? So you get all this pizza. Your mom says, you can have 12 18ths of the pizza that we have tonight. Now, I just want you to take a look, and I know it's not perfect, but take a look. I'm going to use blue here. Take a look at how much pizza you're getting in each one of these. Okay, look. You're getting, oh my God, my handwriting's awful. Okay, you're getting this much pizza in this one, okay? There's a lot of pizza. I'm so
starting
hungry.
to get full now.
I know. I'm
Thinking of that.
thinking about it getting full. I like
Yes.
that. Look at this. Look at this. Look at these shapes. They're almost the same. And as a matter of fact, these fractions right here 2/3, 6/9, and 12/18 are equivalent. If you got to eat 12/18 of a pizza, 6/9 of a pizza, or 2/3 of a pizza, you're getting the same amount of pizza.
So you're telling me with the one on the right that says 12/18, if I ate that and you ate the one that's 2/3, we ate the same amount of pizza?
Yeah, absolutely. We got the same amount of pizza. And I'm going to show you how we know that. Okay, I'm going to write these down as fractions. 2/3, I'm going to write them down with actual numerators up top, denominators down low, because I hate when I side-by-side it. It makes it more difficult for me to think about. So I'm going to line these up top to bottom, and I'm going to show you how I know they're equivalent. Okay, I can pick any number and multiply the numerator and the denominator by that same number, and I have an equivalent fraction. Watch. What's 2 times 3, Mr. Zwick?
6.
Yes, it is. And what's 3 times 3, Mr. Zwick?
9.
That's right. So look, 2 times 3 is 6. 3 times 3 is 9. 6/9. Okay? Now, I want you to pay attention very closely. The numbers that you pick to multiply the numerator and the denominator by have to be the same. Yes. The same. Okay? So look, I've made my fraction 2/3 into 6/9. All I've done is cut it up into more pieces. See? I just took each of these thirds and cut them into 3 pieces by multiplying it by 3.
Wait, can I try this one now, Mr. C? I think I got it.
Sure, let's do it.
Okay, so I see a 6, and I'm trying to figure out how did the 6 get to be a 12. So I got to think of factors of 12. So immediately I go, okay, well, 6 times 1, of course, is 6. It can't be that. So I'm going to go up to 2 now. 6 times 2 is 12.
Now,
Now,
look at that right there.
let me make sure if I check my work. So you said if I multiply the numerator by a number, I have to multiply the denominator by the exact same number. So that tells me that I need to multiply by 2.
Mr. Zwick, I'm so glad I brought you along for this. What's 9 times 2?
9 times 2 is 18.
Boom. Look at this.
Ocho.
Okay? You're going to have to figure out how to find these. And look, you can also use division. Okay? I'm going to write a big division sign up here, one of those old school 1960s division sign. You can also use division. Look at 12/18 divided by 2. What's 12 divided by 2? It's 6. What's 18 divided by 2? It's 9. Look. What's 12 divided by 6? It's 2. What's 18 divided by 6? Mr.
3.
3. Look, all of these fractions are equal. All we've done is change how many pieces we cut them into, okay? So before we end here, if you remember one thing, remember this. The word equivalent means equal, the same. Look, we've taken these numbers here, 2/3, 6/9, 12/18, and we've shown by multiplying the numerator and the denominator by the same number or by dividing it that they're equal. Okay? No one's going to get ticked about getting any of these pizza fractions. If you get 2/3, 6/9, or 12/18, you have no reason to be upset. It's the same amount. No one's gotten more than anybody else. They're equal. The same. Equal sign. Or, if you're of the Spanish persuasion, mismo. Okay? They are exactly the same.
So you're saying, let's say I grab 2/3 of your class to take out on recess, and then I come back in and we come back in and I grab 6/9 of your class, and then we come back in after recess and I grab 12/18. I'm grabbing the same amount of students out to play for recess?
Every single time. Isn't it wild? Isn't that mind-blowing? All right, but we're running out of time, so let's move right along. We're going to hit some of the important learnings. What did we learn here today? And you're going to have to use this a lot to really grasp it. We learned that knowing factors and multiples is going to help us to find equivalent fractions. Secondly, the word equivalent means equal, the same. You can even look at an equal symbol or
Mismo.
Mismo, hey. Yo hablo español. Okay, and then finally, knowing how to find equivalent fractions is going to help you on your quest to be a black belt. Yes! Sensei Judo black belt in mathematics. So level up, folks. You can't move on until you know how to do this. All right? And you can't know how to do this until you actually get your fingers dirty and try. Okay? So try it. Get your hands dirty, your fingers dirty. I don't know. Maybe I made that one up. Here we go.
And so you're ready for 5th grade for me.
Boop. That's right. 5th grade teacher right here. 4th grade teacher, 5th grade teacher. You want to be ready for 5th? You have to know how to do this. I want you to show 2 equivalent fractions for each of the following numbers. And I challenge you to use division to find one and use multiplication to find another one. Here we go. 4/6. The second number that I want you to find 2 equivalent fractions for is 4/12. And then the last one is 5 tenths. Okay? Figure it out. Show your teacher, show your mom, show your grandma, show your grandpa, show whoever it is that is your math mentor. Make sure you get it right, and then you're going to have to practice finding and identifying equivalent fractions before you move on to your next step. Any final parting words of wisdom, Mr. Zwick?
Just work hard, get smart, and you're on your road to college.
All right, we'll see you next time.